Hello, this is Mrs. Poland for AP Statistics Lesson 10.05, and today this video is going to go over the match pair T interval, and it's much easier to understand this by going directly to an example. So teenagers spend an average of approximately 5 hours online every day. Do parents realize how many hours their children are spending online? A family psychologist conducted a study to find out. A random sample of 10 teenagers were selected. Each teen was given a Chromebook and free internet access for 6 months. During this time, their internet usage was measured in hours per day. At the end of 6 months, the parents of each teenager were asked how many hours per day they think their child spent online during this time frame. Here are the results. And so we see a chart with the subject number, the actual hours a day they spent, the parents' perception of the hours, and then the difference. And they did actual minus parent perception. So part A asks, the dot plot of the differences actual time spent and parent perception measured in hours per day is shown below. And they want you to discuss what this dot plot reveals. So you should put the video on hold. So there are multiple explanations. This is just one thing that you may notice. So the differences were going from, I think the lowest difference was 0.9, and the highest difference was close to 5 hours. So that's the difference of the actual minus perceived. What you should also notice is that, again, there were 10 pieces of data, and you can see that 1, 2, 3, 4, 5, 6, 7 out of the 10, the perception, the difference was greater than 2 hours. So that's why the parents consistently underestimated the time. That's why there was a positive difference, and 70% of the parents underestimated by over 2 hours. So that's interesting. The next thing they want you to do is find the mean and standard deviation of this difference and interpret it, what it means. Okay, so when you do a match pair, it almost looks like they're two separate populations, but they're connected together by the teen's result. So it's not two separate sample sizes, but the parent's data is linked to the child's data, and that makes it a match pair design. And so what we do to study it is we take the difference, and you're actually going to be performing a one sample T interval and treat it as if it's just an interval. You're looking at that difference. So we need to get the summary statistics, and so we're going to do that by entering the data into a calculator. And you can call it X, but I'm going to call it difference, or DIFF. And you're going to go into your list and spreadsheets and enter the data. So they do have match pair designs, and this is one of the few times that you would be entering the data, but normally it's a very small data set like this. Most of the time it's smaller than 10. And I just want to check the values before I continue so there are no mistakes. So 3.4, 3.2, 1.7, 4.7, 4.9, 1.8, 0.9, 4.1, 2.7, and 2.8. So we have all our data. And we need the mean and the standard deviation. So you would go control page. This is from the beginning of the year. And a calculator page. And then you would go menu, statistics. We want just regular stat calculations. And we want one variable statistics, one list. Your X variable is X list is difference, and we don't need a frequency list or a category list. We're not doing anything fancy. And we see that we have a mean of 3.02, and then you would use the sample standard deviation, because this is representing a sample of all teens, of 1.316. Again, in general, we try to keep to 3 decimal places. So let's fill that in here. So, sorry about that. So, X bar diff is 3.02, and that's hours per day. And the standard deviation of the difference is 1.316 hours per day. And they ask you in this case to interpret the mean. And so how would you interpret it? On average, I think I wrote it here, the actual time teens spent online was underestimated by 3.2 hours. That's a pretty big underestimation. And that should be a T thought. Okay. Okay, now let's go on to the next. So now they actually, on part C, are going to ask you to construct and interpret a confidence interval of this difference. And so the first thing you want to do is choose the procedure, and this is called a matched pair t-test. Oh, I'm sorry, t-interval. We'll do a t-test next unit. Okay, and you actually treat it as if it's a one sample t, but you're always looking at that difference. And the confidence level is 90%. And then they want you to define the parameter. So you can use mu a minus p, or you could actually, if you wanted mu d, you can even use mu x, but we normally use either the subscript of the two variables we're subtracting, or d, or sometimes you'll see in textbooks diff. And it represents the true mean difference in the time spent online. It's not the difference of the means, and that's like a really important point. So mu a minus p, that subscript, does not equal to mu a minus mu p. This is the mean difference does not equal to the difference of the means. Here you're subtracting two means, and here you're taking the difference first and then taking the average of it. So that's like a really important point to see. Okay, so it's the true mean difference. So you're taking the difference and then you're taking the average of the difference. And then you have to clearly say which thing comes first. Next, we're going to check the conditions. So the first condition is our normal random sample as stated, right? So you're choosing the teen and linking them with the parents. And the second condition is the 10% condition. So again, you can put the video on hold at any time. It's reasonable to assume there are more than 100 teens that could have been participating in the study. And now the third condition, we don't have 30 teens, but if you go back to the dot plot is roughly symmetric. We don't see any outliers. And so therefore, we can apply a normal model. So the dot plot shown appears to be roughly symmetric with no outliers. Therefore, we can apply a normal model to the sampling distribution. So again, that last condition allows us to apply a normal model, or the modified normal model, which is the t-distribution. So then we say, since conditions have been met, we can construct a matched pair t-interval with, and it would be 9 degrees of freedom. So again, we're treating this like a one sample T, and so since there are 10 people in the study, that's why the degrees of freedom is 10 minus 1, or 9. We're now up to the calculations. So the general formula is the statistic plus or minus the critical value, writing the general formula, times the standard error. So the statistic is x bar, and you're really taking the average of that difference. Plus or minus, you're still doing t with n minus 1 degrees of freedom. And then the standard error, if you look back into the formula, it's for one sample, same as one sample, is sx over square root of n. We now want to plug in the number. So for the mean, we got a difference. Let me just look back. It's on that second part. So it was 3.02 plus or minus. You want to leave a space because we have to fill in the critical t. The standard deviation was 1.316 over square root n was 10. To find the critical value, again, you're looking at the confidence level was 90%. So that means alpha over 2 is 1 minus 0.9, or 0.05. So so now you're going to do inverse t. It's 9 degrees of freedom. 0.05, comma, 9. And again, it's really important that you practice using the calculator. So let me just scroll down. So this is going to be menu, statistics, distributions, inverse, I'm on the wrong one, inverse t, and that's 0.05, and that's 9, and you hit OK, and you get 1.833. Now, you could, plug this in by hand and do the arithmetic, but I do want to show you and get you used to just typing into the calculator. Let the calculator do the arithmetic. Once you have the data in 1.2, we could have gotten the mean and standard deviation and done the t-interval all in one step once you enter the data by hitting menu, statistics, confidence intervals, and it's the t-interval, so it's 2. We're basing it on the data set, right? So here's our data. We're not doing summary statistics. You could, but I just want you to see you could have just done it from the data. You're going to hit OK. So it was difference. The frequency list, there wasn't a frequency list. It was just a list. And for the sea level, we want to change that to 0.9. I don't know why that didn't change. Okay. And notice they gave you the same mean as before. They only showed it to one place. They gave you the standard deviation, and they gave you the degrees of freedom, and even more importantly, they gave you the upper and lower limit. So it does make things lovely. Remember, lower is always left. And now we're up to the final step of writing the conclusion. So we are 90% confident that the interval from 2.257, this is hours per day, to 3.783 hours per day captures the true mean difference in the actual time spent online versus what the parent's perception is. So I hope this video was helpful, and I will see you tomorrow.